Hey everybody, Trey here, back with another forecast discussion for today's severe weather event, or more, tonight's severe weather event for the central and southern plains. We have an enhanced risk here from the Kansas-Nebraska border all the way down through the eastern Texas Panhandle into parts of western and southwest Oklahoma. Now they have increased the tornado probabilities from yesterday. There is now an area that has been outlined for potentially significant tornadoes here in this 10% hatched area stretching from almost the I-70 corridor down south to basically the I-40 corridor here in the Texas Panhandle and western Oklahoma, surrounded by a rather large 5% area that does encompass the Oklahoma City metro area. So the tornado threat could exist with storms that move through, especially later on early Wednesday morning. There is a significant hail risk with these storms as well, down here in the same kind of area, and then a damaging wind threat as well. So it's a pretty potent system, and some of you may have already seen the 12Z convective allowing models, particularly the HRRR run, now showing storm initiation here in southwest Oklahoma, where we were pretty dead set that there would not be any during the afternoon here in southwest Oklahoma. We're going to see if that is legitimate, or whether that's just another HRRR falsehood here, and whether or not we see kind of what we were thinking yesterday still, the sort of northwest Oklahoma, southwest Kansas play being the best area for stronger supercells with potential for significant tornadoes. So let's go ahead and dig in here. We'll start off with our water vapor satellite image here. Another beautiful image from this morning. Here is the weakening low pressure kind of area that spawned the Sunday severe weather event in Oklahoma. That's moved off into the Great Lakes region. And here is our trough, beautiful looking trough here that is going to be the player for tonight's severe weather event. Digging down near the Four Corners region that will eject as we go through the day today. Big kind of fetch of mid and upper level moisture here moving over Texas into the southern plains and into the Midwest even. So pretty beautiful satellite image here. We'll go down to the visible imagery here, and let's go to the sub-regional sectors and take a look at what we're seeing here across Texas and Oklahoma. And actually, let me go a little bit wider here so we can see kind of this moisture return. And remember, if you recall yesterday's video, we talked about moisture return and the timing of that return being the absolute key here to who will see the strongest storms first. You can see these low-level clouds, evidence of some moisture flowing onshore. You can see these kind of cumulus streets moving on to the Texas coast here. That is as a result of that Lee troughing, that Lee cyclogenesis that we've seen already, trying to start pulling that moisture northward. And now we'll take a look at the surface map here in a second. You can see kind of the shear that's in play in the atmosphere just from looking at this satellite image. You can see these slightly higher clouds, these wispy higher clouds here moving from out of the southwest, and then this kind of low-level flow at the surface moving from the south or southeast. That is a favorable sign for severe storms later on today and tonight, that we already have kind of wind shear in place, and that will only strengthen as we go through the day today. So let's take a look at the surface map here. We'll start with the Central Plains sector. Let me update it here. And you can already see we've got winds out of the southeast at the surface here, quite strong here, approaching 10 to 15 knots here across much of the plains, kind of feeding up into this surface low here that is located just kind of east of Denver, Colorado here. Starting to draw that moisture up, we are seeing as we go to our kind of southern plains sector here. We can see those 60s dew points are making a return to the north. They've kind of already reached kind of the Dallas-Fort Worth metro area. There's a 60 dew point there. There's Dallas-Fort Worth right there. 60s dew points kind of south of that line, and even upper 70s and 80s dew points here along the Texas coastal plain. So very, very rich moisture, at least at the very low levels here, coming into south and central Texas here. That'll try to be pulled north today and tonight. And we're already seeing some increase here in the dew points in Oklahoma. Yesterday, if you recall, we saw dew points here plummet into the mid-40s. We've already seen them increase into the 50s here. Let's take a look at our Mesonet map here, and you can see we're starting to see some 60s here along the Red River. That will continue to be pulled north today. And we're going to take a look at the timing here. So let's take a look at our 60s dew point line here. So we actually have dew points in the 60s, kind of the Red River down toward DFW and then over to the west. So there's kind of our 60 dew point line. Let's take a look at what the yesterday's NAM was showing. Where's this 60 dew point line going to be? So this is it. We're recording this video just after 15Z, so it's 10:30 a.m. here. This is the 15Z. This is valid for 15Z today. This is yesterday's morning NAM model run. And you can see we've kind of got that. It's kind of got that in place, and we maybe even have a little bit more northward advance of that 60 dew point line based on what we were seeing with yesterday's NAM. This kind of boundary between the blues, which are 60 plus dew points, and the greens, which are less than 60 dew points, headed up here kind of at the Dallas-Fort Worth area. But we are seeing some evidence that that is a little bit farther north, so maybe we are seeing a little bit faster, just slightly faster moisture return to the north than what the NAM was showing yesterday. So that is something to keep in mind for today, that we may actually see this moisture get to kind of the Kansas-Oklahoma border maybe a little bit, just a tad faster than what we were seeing on the models yesterday. Now let's take a look at some soundings here. This is the Norman 12Z sounding, and it's not really what you want to see on the day of a severe weather outbreak, but keep in mind that this, again, is going to be kind of what we call a just-in-time moisture surge. So we're going to see these kind of not very favorable profiles here as far as thermodynamics go in the low levels for much of the day, at least until mid-afternoon, when that moisture starts to get to the Oklahoma City metro area. But you can already see that wind shear in place. We've already got looping hodographs here, long looping hodographs, S0 to 3 surface, 0 to 3 storm relative helicity of over 200 meters squared per second squared already. And as that low-level jet ramps up with continued cyclogenesis later on this evening, we should see these hodographs only get larger, potentially favoring strong tornadoes in any discrete convection tonight. But let's go south to Dallas, see what they're seeing, and a little bit more moist of a profile here, in at least up to about 600 millibars here, a little bit more moisture throughout the profile. Already some elevated instability there with some steep lapse rates aloft. That steep lapse rate layer there, maybe some evidence of a remnant elevated mixed layer there. Let's go down to Corpus Christi. If you recall, yesterday we were seeing a deep mixed layer there, and we're still not seeing anything different there. There is a little bit of an inversion there between about 800 and 600 millibars there. But we are seeing a still quite deep moist layer, so that will continue to be pulled north throughout the day today as we get that low-level jet to continue to ramp up throughout the day. Let's take a look at our mesoanalysis maps here. Here's our 500 millibar trough. This is for 14Z. So this is going to be for 9 a.m. They're a little bit behind here with the maps. Not quite caught up here. Yeah, this is 14Z, so this is a little bit outdated, but still gives a pretty good picture. Big bowling ball closed trough here at 500 millibars. Big old strong speed max rotating around the base of that. And so given this, we've already got flow traversing the Rockies, so we should already have seen the start of cyclogenesis here, and that is definitely the case. We see this big kind of broad cyclonic circulation here centered over Utah and Colorado with a pretty potent low-level jet already in place. So that is going to really help this moisture surge northward throughout the day today. And if we go down to our surface map, you can kind of see that already. We've got winds, strong winds out of the southeast here. Big kind of surface low already in place, and that will only kind of consolidate here as we go throughout the day up in northeast Colorado. And when we see that kind of consolidation, we'll get this low-level jet to strengthen even more and really start to pull that moisture northward. So I think we're pretty much kind of on track for yesterday. We should kind of see, still we're going to see this kind of just-in-time moisture, but we should see that kind of get to the Oklahoma-Kansas border, I think by about 0Z or 7 p.m. tonight, and then that'll continue to surge northward throughout the evening tonight. So we've got wind shear in place, big kind of trough here at 500 millibars, strong winds out of the southwest, and beneath that we've got very strong winds out of the south-southeast here at 850 millibars and out of the southeast at the surface. So we should see, just conceptually, a very favorable environment for supercell storms as far as wind shear goes. And when that moisture makes its makes its way northward, that's when the instability will really ramp up, and we should see a collocation of really favorable instability with really favorable shear for potentially significant supercell thunderstorms later this evening. Now let's take a look at the NAM here. This is just kind of see how it progresses throughout the day, just to kind of get maybe an idea of how things are going to go throughout the afternoon. There's our trough there, pretty good depiction here at 12Z. That continues to eject into the plains. This is at 21Z. And then by 0Z, we start to see that centered over northwest Colorado. That big kind of jet speed max there, rotating around the base of it. A little bit more meridional flow here up in Kansas, a little bit more north-south flow here, whereas in Oklahoma, once again, we're seeing a little bit more southwesterly flow, perhaps a little bit more perpendicular to the initiating boundary, which we'll look at here in a second. Now, I'm going to jump to the HRRR here. This was the 12Z run, and runs after that have continued to show this kind of scenario where we get to see daytime initiation here in southwest Oklahoma of supercell thunderstorms here by about 0Z, so in the daylight. And then they move off toward the northwest, coming close to the Oklahoma City metro area there. Now we've got to see what's going on here. Is this validated by our conceptual models here? So if you look at our 500 millibar map, we should have enough forcing by 21 to 0Z. Kind of this, as this speed max rotates near the plains, will be kind of in the exit region there. So we should have ample forcing aloft, at least in the background. But do we see any sort of short waves here? This is at 700 millibars, and I'll zoom into the southern plains sector here so we can get a better look. And we're trying to look for little kinks in the flow. So for example, here's a little shortwave here over southeast New Mexico into West Texas. These little kinks in the flow that show up kind of best here at 700 millibars. We're trying to see if any of those rotate through here during the daylight hours for southwest Oklahoma. Because if you have broad flow and broad lift over a large area, oftentimes you won't get storms unless you have kind of this focused sort of area of lift from this shortwave. So let's see what we see here. This is at 21Z. Maybe some semblance here across the Texas Panhandle, a little bit there. And then by 0Z, we start to see a little bit of a kink here in the flow. So I do think it is plausible, at least based on the NAM here, that we will get storm initiation down in southwest Oklahoma by 0Z. But again, this is at 0Z, and the shortwave is still lagging back here south and west, south of the Red River here. So I don't expect anything before 0Z here. It doesn't appear that way, at least. And then let's take a look. Let's take a look at our low-level jet here. We'll zoom back out here. So this is at 850 millibars. You can already see a strong low-level jet in place. That will continue throughout the day. This is at 0Z, just a broad swath of 40 knot plus 850 millibar winds here, even down south toward the Del Rio area, all the way up into the Dakotas. And as we go just a few hours past sunset, this is at 10 p.m. tonight, we really start to see that low-level jet ramp up, especially over Kansas here by midnight. Really strong winds here in Kansas, perhaps convectively contaminated a little bit, but overall just a broad swath, very favorable for tornadic storms here if they can remain semi-discrete. And even if we do have a squall line here, there could be a number of embedded QLCS circulations here come the overnight hours. So let's take a look at our moisture return here on the NAM, see how it's doing here. Let's go back to our southern plains sector here. So this is at 15Z. We kind of see that here's that 60 dew point line. Again, we may be even seeing that slightly farther north than what this model output is showing. So this is at 18Z. 21Z, we already see kind of this 60 dew point line by 4 p.m. here up to the Kansas-Oklahoma border. And that is a little bit of a development from yesterday when we weren't really seeing that until after 0Z. And this is at 0Z, we see that 60 dew point line get across the Kansas-Oklahoma border, and the real rich moisture starts to impede or encroach into southwest Oklahoma, into the, just north of the Red River. then we get continued moisture advection throughout the evening, and this is kind of interesting here. So normally, what we see is when we start to lose sunlight, and we start to go into the early evening hours after sunset, we start to see the surface temperatures cool, and as a result, we start to see stability start to form near the surface. So any storms usually that are ongoing here at night become elevated. They lose their tornado threat. But when you have a situation like this, when you have continued strong moisture advection, warm moist advection here in the overnight hours, what that can do is it can actually offset the cooling near the surface and actually kind of offset that stability that starts to build back in. And we've seen this in many types of events. For example, the Greensburg, Kansas F5 tornado of May 4th, 2007, the Plains, Kansas nighttime tornado outbreak here in southwest Kansas. In those cases, we had a real strong low here out in southeast Colorado. We just got this continued fire hose of warm moist advection here into southwest Kansas. And I think that's going to be the case tonight as we continue to see this moisture advection throughout the overnight hours. That's going to offset the diabatic cooling, as we call it, that starts to get that convective inhibition to build back in. Instead, we're going to see these storms, I think, continue to be surface-based here as these higher dew points continue to stream in. And so that would allow the tornado threat to persist even into the overnight hours when oftentimes that's not the case. So here's our surface map here. Kind of see this broad surface low, kind of two different centers here over kind of west central Kansas and then one up in Nebraska. There's our 60 dew point line up toward the I-70 corridor there. And let's take some forecast soundings here. We'll go back toward 21Z, back when we were seeing that initiation on the HRRR. Let's take a sounding here from around the Frederick area. And so the NAM is showing that we're still capped. So that is going to be an issue here, that remnant kind of EML in place, at least on the NAM here, should hold off storm development in southwest Oklahoma. And we're only seeing surface temperatures of 73 degrees here. So that is why we're seeing this kind of inhibition remain here in southwest Oklahoma. But profile is favorable. There's a little bit of a kink there in kind of the low levels, but low level profile definitely favorable for tornadoes there, but I don't think we're going to get storm development there, at least based on the NAM here, before 0Z. Now let's look at 0Z, and that's an interesting feature there. This is what we call a dry line bulge. And oftentimes storm chasers know to kind of target just to the northeast of that dry line bulge, because that's where kind of the strongest winds are coming out the backside of that, the strongest forcing is. You can often get a little bit stronger storms there just to the northeast of that dry line bulge. And then by 0Z, southwest Oklahoma, we're still a little bit of surface-based inhibition here remaining. But we do see we're getting closer here to possible convective initiation in southwest Oklahoma. And we've actually kind of worked out that kink here in the hodograph. Hodograph's becoming more favorable here. Even by 0Z, we're already seeing upwards of almost 400 meters squared per second squared effective helicity here. Large looping hodographs here. So if we can get storm development here in southwest Oklahoma right before or near sunset, which is a big if at this point, based on the NAM, I just don't see anything to force storms here in a concentrated area in southwest Oklahoma before 0Z. But if that does happen, the profile will be favorable for perhaps tornadoes, at least large hail and damaging winds here. And then so let's take a look at 0Z here up in northwest Oklahoma around the Woodward area. Just kind of where we were eyeing yesterday. That's even worse here on the NAM. 66 degrees at the surface. That may be even a little bit cool here. Let's go to the Mesonet and see where temperatures are now. Just to see, we must keep in mind that we are going to see some kind of warm advection showers, so some elevated showers and thunderstorms here across much of Oklahoma throughout the day, just forced by this northward push, the surge of moisture, what we call this warm advection regime, is enough to kind of force these elevated storms kind of over a broad area. So that may keep temperatures a little bit down throughout the day. And we're only in the low to mid 60s here up here, but given the satellite presentation and there is some cloudiness that still remains. Would expect that to kind of burn off somewhat throughout the day, and we at least will see some warming up there. So 66 degrees may be a little bit cool here, but nonetheless, a large looping hodograph here in the low levels by 0Z up in northwest Oklahoma. And then we'll go up into southwest Kansas, just on the leading edge of those 60 dew points. Kind of much of the same. NAM still very, very capped here. And I think oftentimes the NAM is a little bit too strong with the cap, a little bit too cool at the surface. And then by 3Z, so this is 10 p.m. Central Daylight Time, we'll go southwest Oklahoma. Still a little bit capped down there, still a little bit of an inversion there. So that'll be something we have to watch, but very favorable photographs for tornadic supercells, almost 500 meters squared per second squared effective helicity. And we'll go up to northwest Oklahoma here once again. Still kind of capped here. I'm going to say that this is a little bit erroneous here. I'm not going to quite believe that capping is going to stay in place there. Just given the warm, moist advection, that's going to be just kind of this continued fire hose here up into northwest Oklahoma and into southwest Kansas. I just don't see this happening. I don't think we're going to cool off a whole heck of a lot. If, say, we warm into the upper 70s today, I just don't see us having that real strong inhibition remaining, given that we're going to have that real strong low-level jet just consistently keep that moisture surging in overnight. But nonetheless, if we get surface-based storms, they will have a strong tornado threat for sure. Almost 600 meters squared per second squared effective helicity here. That is big time. If any storms can remain discrete in that environment, it is going to be pretty crazy there. So this is at 6Z, so this is almost getting toward the, this is going to be, what, 1 a.m. Central Daylight Time. We'll go up here, up kind of in southwest central Kansas. Yeah, I just don't buy that. I really don't buy that from the NAM. But you can see just a large looping hodograph, 0 to 3 effective, 0 to 3 helicity, over 700 meters squared per second squared. That is big leagues right there. Northwest Oklahoma. There we start to see it be a little bit more surface-based once those 70s dew points start to surge in. Little bit less inhibition, minus 61 surface-based convective inhibition there. That is definitely breakable. So this is when we could start to be seeing more of a strong tornado threat with any discrete storms up there in northwest Oklahoma. Once again, big wind profiles there. And then southwest Oklahoma toward, we'll go just southwest of the Oklahoma City metro area. Kind of the same thing, a little bit less inhibition there, still some remaining. But once again, large looping photographs there. So I think the takeaway here from at least the NAM is, and I'm not sold on the low-level thermodynamic profiles. I think it's maybe a little bit too cool, kind of underrepresenting that moisture advection, continuing to offset that cooling near the surface after dark. But let's take a look at storm mode here real quick, at least on the NAM. For at least roughly, we've kind of got this, we'll say a north-south oriented dry line here. A little bit of a bulge here on the NAM. So we'll say roughly a north-south oriented dry line. Now let's go ahead and look at our upper level winds here. Go to 0Z. And you can see up here in Kansas, the winds here in the upper levels are pretty much north-south as well. So I think up here into Kansas, the farther north you go, the more likely things are to line out more quickly, which would in turn bring these places like Dodge City, Garden City, Greensburg, up towards Scott City, up toward the I-70 corridor, more of a damaging wind threat and perhaps an embedded tornado threat up here into Kansas. But as you go down southward into northwest Oklahoma, and then even into southwest Oklahoma, assuming we can get storms to fire there, notice how the winds are a little bit more, they have a little bit more of a perpendicular component to that north-south oriented dry line. As a result, I think there's a little bit better chance for a longer window of discrete storms down here with southern extent. And then any discrete or semi-discrete storms down here would have a strong tornado threat given the just ridiculous low-level shear that we were looking at in those forecast photographs. as well as a very large hail threat and a damaging wind threat. I think eventually, once the main forcing really starts to arrive after midnight, we'll start to see this kind of line take shape. Still more of a perpendicular component down here into Oklahoma, so Oklahoma City metro area will have to watch for maybe some semi-discrete storms near the tail end of this line as it plows through in the early morning hours down here into the Oklahoma City metro. There is a tornado threat, I think, that would accompany storms, embedded circulations along the line, just kind of like what we saw on Sunday as that squall line moved off past the Oklahoma City metro area toward the Tulsa area. We started to see these little just spin-ups happen fairly frequently along that squall line. That's, I think, kind of what we're going to be seeing here as we go into the overnight hours and early morning hours Wednesday. So this, to me, looks like kind of a nocturnal event. Let's take a look here. We'll take a look at all the cams here, just kind of for, I don't know why we look at the cams anymore, but just for giggles here, we'll look at the cams. This is the 12Z HRR, 12Z HRRR. You can see those kind of warm advection showers throughout the day. These will mostly be sub-severe. Would not expect any severe weather out of these. Maybe some small hail approaching severe limits, maybe some stronger winds, but these will be elevated. Will not have a tornado threat throughout the day today. And then by 23Z, we start to see daytime initiation up here, closer to that surface low in northwest Kansas, southwest Nebraska, which is definitely plausible. I don't think there's anything wrong with the idea that we'll get storms closer to that surface low where the forcing might be a little stronger, the air might be a little cooler, aloft, a little bit better instability up here later on. But as we know, the dew points are going to be pretty terrible up here for a while. Only 55 dew points, which in the high plains can get it done, but real meager instability here. But photographs are favorable for supercells here, but I would think they would have a tendency to maybe be a little bit more outflow dominant given the just overall lack of moisture up here until later on this evening. And then the HRRR continues to fire those storms here in southwest Oklahoma. This is at 1Z. We'll take a sounding ahead of those. And yeah, we're almost uncapped here. There's a little bit of an inversion left there, but large looping photographs there. So if storms can fire, which I think is a big if down here in southwest Oklahoma, I don't really see any concrete evidence of that happening here later on today. But if it can happen, I think these would have a threat for tornadoes. But you know, the later they can hold off, the better the tornado threat will be, because that's when the better moisture will arrive. And then you can see stuff start to fire here in western Kansas, then down south along the line here. Yeah, these storms up here, I think, still going to be elevated after dark. Probably just a large hail threat up here with these elevated storms. And then we start to see by about 3Z or 10 p.m., we start to see storms fire here closer to where the best kind of overlap of the parameter spaces will be. Dodge City area, down toward Buffalo, Laverne, the eastern Oklahoma Panhandle, into the Texas Panhandle. And then these storms could be supercellular very quickly. The HRRR is also kind of showing that inhibition there remaining just above the surface there. So that's interesting. These storms may be a little bit elevated here. So that'll be a question we'll have to watch. Are these storms going to be elevated or not? Are we going to get surface-based storms out of this? So this is an interesting depiction here. HRRR says we have a chance for southwest Oklahoma initiation. But again, I'm not really buying that. Let's take a look at the latest HRRR that's coming in. We'll go to the 14Z run, see if it's changed at all. Okay, here we go. This is at 23.0Z. So here we go. 14Z run is dry here in southwest Oklahoma until 1Z. It starts to fire those supercells near the Altus area up toward Lawton, and that is a pretty scary profile there. That is an interesting profile. Very much almost uncapped here. Surface-based convective inhibition still remains. Mixed layer much less than that. But large instability here. Mixed layer cape of almost 3,000. Very large looping photographs. Effective helicity of 600. So if this does come to fruition, this is plausible here now. Now we started to see on the NAM that shortwave, that those little kinks in the ISO heights up there at 500 millibars, or our kind of pseudo sort of pressure lines up there at 500 millibars. That kink started to move into southwest Oklahoma just after 0Z. So I think this is a plausible situation. We could get storm development here after dark here in southwest Oklahoma, but I don't think there's going to be anything before dark. I think this is a more plausible scenario here. And as a result, the Oklahoma City metro area would have to kind of watch out for this as these storms move off to the northeast by the 10 to 11 p.m. time frame tonight. Then we get a more messy mode up here as we expected up into Kansas, a little bit more linear, more quickly. But then we get maybe a little bit more isolated development down here in northwest Oklahoma by midnight. And then we get kind of more storms developing down the line here. If we have any semi-discrete storms here, again, I think there will be a strong tornado threat with these, but the HRRR pretty confident with a more linear orientation to these storms. These down here in western Oklahoma could have a tornado threat as well. Let's take a look at the ARW. This is the WRF ARW. We're just going to take a look at kind of all the cams here to kind of get a big picture. You can see these warm advection storms sub-severe throughout the afternoon today. And then interestingly enough, the ARW not firing anything here in southwest Oklahoma. We do get storms in the eastern Oklahoma Panhandle with pretty significant rotation being progged here. Can't pull soundings here, but if these, maybe this southern end one here, just north of the Buffalo area, near Laverne, would have a significant tornado threat there. And then we kind of get this line to develop overnight and into the early morning hours Wednesday. And then finally the NSSL WRF here we'll take a look at. Once again, I like to use this model. I trust it a little bit more than the others as far as storm mode goes. There's all that rain and storms here early on, sub-severe. And then you can see nothing here in southwest Oklahoma throughout the day. Even after dark, not showing much here in southwest Oklahoma. Then we kind of get this quick transition to a linear mode here. So storm mode concerns do remain. I think the meteorology does show that there is a window for discrete storms, particularly with southern extent down here in far southwest Kansas, down into the eastern Oklahoma Panhandle and eastern Texas Panhandle into western Oklahoma. Better chance for discrete storms down here. So we will have to watch, see if the HRRR is correct, see, number one, what the surface temperatures do throughout the day. Again, I think the NAM may be just slightly cool with those, but we'll see. We'll see what the effect that the afternoon storms have on this area, whether or not we get significant warming. Number two, we're going to have to watch that degree of moisture return. How fast do those 60s plus dew points get into southwest Kansas, northwest Oklahoma? We'll have to monitor that throughout the day. And then I think that's going to modulate the severe threat. Whether or not we can overcome that cooling after dark, and we can get surface-based storms. And if we can get surface-based storms that are somewhat discrete, I think particularly that'll be the case here, at least most likely in far southwest Kansas, northwest Oklahoma, the eastern panhandles here, down perhaps into southwest Oklahoma. We'll have to watch that area to see if we do have a little bit more chance of initiation here throughout the day. I think we will have a strong tornado threat with any of these storms, just given the overall really ridiculous wind profiles that we were seeing. But that is, again, if they can be surface-based. If they're not, then we won't see a tornado threat. Perhaps just once the swell line forms, we'll see embedded circulations, but nothing really like a strong long-track tornado threat. But we'll have to keep an eye on those things throughout the day. Once again, enhanced risk here from southwest, or from the Kansas-Nebraska border down into southwest Oklahoma, the eastern panhandles. So if you live in these areas, if you live in the orange area in particular, and they're about to come out with a new outlook here in about 20 minutes, so we'll have to look at that as it comes out too. But if you live here, even the Oklahoma City metro area, down toward Lawton, Wichita Falls, gonna have to keep an eye on things today. So keep your weather radios handy, stay tuned to your local news stations, and we'll get through this. So that's all I've got for now. Thanks for watching. If you're chasing today, stay safe. If you live in these areas, stay safe as well. And after this, we should have a little bit of a quiet period. So if we can get through today, hopefully without any real damaging storms, we'll be set after this. So that's all I've got for now. Thanks for watching, and we will catch you in the next video.